This lecture's topics is over occupational risks. We're going to cover several things under occupational risks. We're going to cover the background, historical events, what led to basically the creation of occupational safety. We'll cover some injuries and fatalities, core elements of safety in the health programs, what hazard identification is, how it's used, and we covered the risk matrix last lecture, but that comes back up under hazard identification. And we'll talk about the hierarchy of controls. First, we're going to start with the historical background of safety and how it came about. So, occupational safety has really been around since the beginning of time. The ancient Egyptians and Babylonians, as you can see, they used slave labor for most of their construction projects. Most people throughout history used slave labor or serfs in the European lands. They used um, the poor people that worked their lands to build castles and to build um, all their other things. But in Egypt, they had laborers' health and safety. It wasn't considered until it was needed. But the Egyptians identified that if they gave their slave workers medical exams and medical care, they actually worked longer before they had to be replaced. The Egyptians also identified that if you fed them better and housed them better, that the even though they were slave workers, they still would perform better. They'd work harder and they'd work longer before being need to be replaced due to an injury or an illness. As we fast forward to the 1500s, there's two key people that you should know: Philippus Aurelius and Georgius Agricola. So Philippus Aurelius was a chemist, a healer. He was a philosopher. He's the first real person that's known to clearly identify that the dose makes the poison. So tie us back to what we learned about toxicology. Some of what he did was to test out different treatments by experimentation, by mixing things together and then seeing how people reacted to it. At the time, he was looked down upon because everybody thought he was just poisoning people, and that's where he came up and said the dose makes the poison. Uh, he's documented in his book here, The Miner's Sickness and Other Diseases. It's a book he wrote that documented the occupational hazards of metalworking. And not only that, he included treatment and prevention to keep miners healthier longer so they could continue to work. Georgius Agricola, he's considered the father of geology. Um, Big into the earth and fossils and minerals. Lots of things are still named from what the name he gave them as he found them in the earth. But one of the other things that he identified with is not just the mining activity itself, but the technology that was being used to conduct mining. And so one of his things is he identified that if mines have ventilation, the fresh air will move into the mines, and if there's fresh air, you have less miners becoming sick. Fast forward again another 200 years, um, you have this gentleman named Bernardino Ramanzini, and he wrote a book called The Discourse on the Diseases of Workers. And he was one of the first people to truly visit workplaces, observe the workers, and then conduct scientific analysis of workers and the diseases they were getting. So again, you come back to what we've talked about in the past. He was studying the correlation and the causation of a worker's um, environment and what types of diseases they were getting. And this book that he wrote was outlined very thoroughly, chapter by chapter, based on different diseases, where he saw those diseases, what types of workplaces the workers are in, ages of workers, sex of workers, race of workers. He really conducted one of the truly first scientific studies linking workers and diseases to their environment. Uh, all the way from the 1700s up to the Industrial Revolution, you had small pockets of people um, working to better understand diseases and everything. And you came to the Industrial Revolution, and it was the introduction of steam power, industrial machines. It was the introduction of the assembly line system, and because of this, we introduced large, very dangerous machines. And you also had a large child labor issue, which in some countries still goes on today. But during the Industrial Revolution, it was not uncommon for children to work in these factories to help their parents out and help to pay for food. And obviously, it was the poor and the destitute that were working in these factories. They weren't paying well, but as soon as their children could work, they were going to mines and they were going to factories and doing odds and end jobs. As you can see, the two children in the picture, um, what seems to be some type of garment factory. They're uh, doing something on a garment press, it looks like. Lots of moving parts around those children. And it was a very dangerous situation, not only for children, but for all workers. Uh, in the 1860s to 1890s, you started getting into some of people were realizing that we needed to put some protection into place. The first machine guard was patented. For those that don't understand or know what a machine guard is, it is a cover or it's a barrier in between the worker and a potential hazard. And that hazard could be a cutting blade, a nip point, rollers, any type of moving part, so a piston or any type of rotating part. That's what a guard is put into place for, is to cover that up and reduce the hazard or eliminate the exposure, which we'll talk about a little bit later. Um, you also had the Bureau of Labor Statistics was formed. For those who don't know what the Bureau of Labor Statistics is, they are a great resource for information. They collect censuses, they collect injury and occupational safety data, which we'll also see a little bit later. Uh, they collect worker by type, by occupation, uh, race, sex. Um, they have all kinds of data on the United States and the workers, and there are some world data also. You had mine safety laws come about, and you had some employer liability laws. Still not much really protecting the worker, but it was starting to generate new laws and new ideas to protect the worker. We covered the Triangle Shirtwaist Factory fire. Here's two videos if you would like to review that. But the main information you're going to need to know for an upcoming test would be right on this slide here. The fundamental changes of that 1911 Triangle Shirtwaist Factory fire were workers' comp laws, the creation of the National Safety Council, the creation of the American Society of Safety Professionals, and the creation of the National Fire Protection Association. Now, the one thing that directly came from the Triangle Shirtwaist Factory fire was workers' comp laws. The other three organizations were created based on a need of professionals to be able to get together. And the Triangle Shirtwaist Factory fire sparked that idea. I'm not saying that the factory fire created them, but it sparked the idea for professionals to come together and talk about safety and how we could better protect the workers. National Fire Protection Association talks about fire safety, building materials, how public areas should be built, etc. So from 1911 to 1970, remember OSHA hasn't been created yet, but over this 60-year span, there's a general increase in the workplace safety, and you can see by the chart the worker injury rate declines. Now, the chart, how you read this is a rate per 100,000 workers. So if you go to the year 1966, we'll say, and you followed up, the chart shows that there were 20 uh, injuries per 100,000 workers in America. That's how that rate is figured out. Going back to the Bureau of Labor Statistics, they actually find the rate per industry or type of job. So again, if you ever need anything with statistics on injuries or illnesses or fatalities, um, go back to the Bureau of Labor Statistics. They have an enormous amount of data. So another uh, part of history that's tragic was the Hawk's Nest tragedy, and we'll watch a short video here in a second. But what it was is workers were drilling a tunnel in the mountains of West Virginia. They were drilling for 10 and 12 hours a day, and the mountain rock that they were drilling through actually had a high silicosis content, or silica content, I'm sorry, which leads to silicosis. And what was unusual is that workers were dying of silicosis, which is a disease, occupational disease in your lungs, within a year. And as you can see, normal exposure to silica takes 20 or 30 years to show up. 476 workers died from it, and we'll watch a brief video.
In the 1930s, hundreds of men were hired to dig the Gauley Bridge Tunnel in West Virginia. They, too, were ignorant of the risks they ran. Desperate for jobs during the Depression, they worked with virtually no protection in a tunnel thick with silica dust. 476 men died here from silicosis.
My name is Walter Kincaid. I worked in the tunnel 4 or 5 weeks. Every day I hear of someone dying with silicosis. I worked until I got sick, and the doctor told me that it was silicosis. And he also told me that anyone that worked as much as 24 hours would not be living 15 years. I think something should be done for our wives and family after we are gone.
Once again, after the deaths, there was a public outcry.
I personally believe that 2,000 men are doomed to die as a result of ruthless destruction of life by American industry.
The next year, 1936, the Walsh-Healy Act was passed. Although it only applied to contractors doing business with federal agencies, it was the first time the government directly imposed health and safety standards.
So after the Hawk's Nest silicosis disaster, you had the Walsh-Healy Act. Basically, what it said is it provided respiratory protection for government contractors, as you can see. It was the first safety law, and it's the first considered safety and labor condition. But it did not extend into non-governmental industry. So if it wasn't a bridge or if it wasn't a government contract, the Walsh-Healy Act didn't apply. But it's important because it comes in 1936. It identifies that we actually have a need for legislation for health and safety laws. And you can read the screen, but 1970, there was no, up until 1970, there's no no OSHA, there's no EPA, there's nothing existing to protect workers or even the employers at the workplace. 14,000 people were dying every year from job-related accidents. You can see the number: 2.5 million workers had become disabled, and 10 times as many person days were lost for job-related disabilities as from strike. So what's that saying is, even though people, this was during the era that unions became around, and you'd have people go on strike, and that would shut down entire factories, or it would shut down a section of the docks in a city. 10 times as many days were lost, days of work were lost due to people being injured than they were from the actual strikes. And the estimated new cases of occupational diseases totaled right around 300,000 per year. Remember, some of the things that they were doing, and silicosis is an example, is that they had no personal protective equipment. They were doing these hazardous jobs, dealing with chemicals that they didn't know what were going to do. And 20 and 30 years later, they're getting a cancer or silicosis or asbestosis, and they were beginning to die. But it wasn't, America wasn't on top of it until 1970. December 29th, 1970, President Nixon signs the OSH Act, and this authorizes OSHA. So the difference here is that the OSH Act is a small document, and we're going to cover what is probably the most important part on the next here, but it's just an act. It gave the right to create the administration. So OSHA actually wasn't created until 1971, which, if you look at when the act was signed, December 29th, 1970, there was only 2 days left in the year, but the administration, the OSHA administration, was not created until 1971, and it was given the responsibility of protecting workers' safety and health. So the mission, this is important. You should remember this, not necessarily verbatim, but I guarantee this question gets asked. The mission of OSHA is to save lives, prevent injuries, and protect the health of America's workers. One of the things that's not in that mission statement is property. OSHA has nothing to do with protecting property or the environment. OSHA is to save lives and prevent injuries. Some of the things that OSHA does, they create regulations, they help create regulations, they enforce the regulations, and they do inspections. The inspections, there's many different types, as if you're a safety student you know, but there's job-related injury and illness reporting that goes to OSHA. There's record keeping by the employers that go to OSHA, so that they can verify that you have a health and safety plan at your business. And one of the things that I think people forget is that OSHA provides training programs to businesses that need help, and this is help in making a plan, enforcing their plan, or if a business goes into some new type of industry, helps them identify what their new hazards are and how they need to change their plans. OSHA is not a money-generating administration. That is, if OSHA enforces a regulation with a fine, OSHA doesn't get that money. The money goes to the Federal Reserve is what it does. But a lot of people look at OSHA and say, oh, well, they're just out to make a dollar. OSHA doesn't make any money off their fines. If OSHA fines a company $100,000, that $100,000 is paid to another part of the government. As where with the EPA, if they level a fine, you pay the EPA the money. OSHA does not make any money off of their enforcement of regulations. So this is the important part of the OSH Act that we just talked about. There's this slide and the next slide, and this comes from Section 5A and 5B of the OSH Act. This is the employer's responsibility, and it's called the General Duty Clause. And it says, the employer shall furnish to each of employees a place of employment which are free from recognized hazards that are causing or likely to cause death or serious physical harm to his employees. Now, the key words in this is, the first word is shall. Shall means that the government is telling you, you will do this. It's not a recommendation. It's not hey, could you do this? It's a, you shall do this. And what it does is you're giving your employees a place of employment that is safe. And the other key word is recognized hazards. And we'll talk about hazards a little bit later. But recognized hazards is a hazard that's recognized by a professional, an employee, the employer, or industry standards. And I'll give you an example. Everybody knows that working on top of a building next to an edge on a construction site, so you're building a building, most people know that those workers need to have fall protection on. And that is because it's been recognized that that person is above, they're on a second floor and they could fall. The hazard is falling off, and the employer needs to furnish equipment, which would be a body harness and a lanyard, to help prevent that employee from being injured. That's a very, very narrow way to look at it, but again, the General Duty Clause is a very important piece of the 5 Act. The OSH Act. It's 5A. The other part of 5A are specific standards. Shall comply with occupational safety and health standards promulgated under this Act. What this is saying is the employer shall comply with the CFR, the Code of Federal Regulations. Those are the standards that fall under the Act. And we say this is the General Duty Clause because if you look through the CFR, and for you safety students that have taken the OSHA class or the construction safety class, you understand how big the standards are and how they're written, and sometimes they're not written well and they need to be interpreted. But if you go through that whole standards book and you can't find a specific standard, yet there's still a hazard or an exposure to an employee, the OSHA inspector can actually cite and give a violation based on the General Duty Clause. There's specific ways to do that. We're not going to get into this class. Just know that what the General Duty Clause is and who it applies to, and in this case, 5A applies to the employer, and then 5B, it applies to the employee. And again, it reads, each employee shall comply with occupational safety and health standards and rules, regulation, and orders issued pursuant to this act, which are applicable to his own actions and conduct. Employee misconduct can be used as a defense by employers. Now, what this is saying is that each employee, if their employer, so the employer gives you personal protective equipment and says you need to wear this to safely do your job, and you as an employee say, I don't want to do that, I'm going to do it however I want, the employer can then, in layman's term, fire you from the job for misconduct because you're not following the standards. Employers can put into writing safety standards that are above the minimum, and the minimum is OSHA. So they could put in standards that are above the minimum, and as long as they're following it throughout their whole company, employees have to follow it if it's a safety and health rule. But again, going back one slide, employer's responsibility has to furnish the employee a place of employment that is free from recognized hazards. Recognized hazards is that key word. The employee has to then follow the OSHA standards, and they can be punitively punished if they do not. So now we're going to talk about the safety basics. There's lots of OSHA resources. There's no prescriptive standards of the recommended practices for safety and health programs. These are voluntary information put out by OSHA. It was published in 2016. It's a recommended document, but it's not mandatory. However, most people, if you do look at it, you find, especially if you're starting a new business and you have to do OSHA and you have to follow them with your employees, it's a good guideline to get your program up and running, especially for small companies. So the core elements of this program are management leadership, worker participation, hazard identification assessment, hazard prevention and control, education and training, program evaluation and improvement, and then communications and coordination. And you need to communicate with the employee, any contractor, and any type of temp staffing agencies about your program. So we're going to cover these a little bit, just wave top them. So for management leadership, you can read what's on the screen, but management leadership in safety is that you have to have a top-down approach. You have to have management on board saying safety is a priority, showing the employees below them that they do care about them and that they want to see significant safety changes take place, or safety is very important to them and they don't want to see them get hurt. If you do have leadership that does not participate or does not show enthusiasm for safety, it'll filter down to the workers where they can also get the attitude of well, why do we care if they don't care? The leadership has to make the employees feel that safety is a core organizational value. That the worker safety is above whatever widget they're making. Money is not the root, is not the only thing that the company cares about, but worker safety. They also need to be committed to eliminating hazards. They've got to provide resources to the employees, give them training, and the big one is the last bullet down here is setting the example. Many times I have seen in my own personal life that you have a policy, you have something in place, and then you want the employee to follow it, but then their direct supervisor is not following it, and it's very hard to implement that. Worker participation. Workers, this one's really simple. The workers have to have buy-in. You can do this by creating open forums, listening to the workers, what their concern is. If they do have a concern, fixing that concern or investigating it to show that you care about them, you care about their safety. Another way you can do it is with safety committees, where you select people from the workforce. They come in, they sit down, you discuss what issues they have, and you go out and you take an active interest in fixing it and improving the safety, and the employees should be a part of that improvement, and they should take an active role in it. Hazard identification and hazard assessment or risk assessment, which we talked about. This is the root cause of identifying hazards, and I'm sorry. This is hazard identification is the bread and butter of identifying what is safe and what is unsafe and how you fix it. Without a good plan to identify hazards and then assess them and then correct them, having a safety plan kind of goes out the window. So hazard identification assessment is a systematic approach to identifying hazards. It's through inspections, it's through checklists, it's through injury and incident reviews. If a worker is injured, one of the part of investigating that injury is to understand why and how he got injured. When doing this, you never you go in with an impartial thought. The employee was injured. Why and how did he get injured? Doesn't matter what the employee did in the beginning. That gets into human factors and stuff like that. But unless the employee was negligent or just blatantly disregarded safety, you got to find out why they were injured, and you got to fix it so another employee doesn't. So you conduct a hazard assessment, and it determines what type of injuries could occur. The line underneath there is very important. There is no hazard without an exposure. And I will give you an example of this. Safety students should understand. But this key point right here, there is no hazard without an exposure, will show up on your test. I promise you that. If you have a fan, whether it's a large fan or a small fan, OSHA has a requirement that says that the fan blades, the rotating blades, will be guarded. That means they have to have a cage on them or something like that. And it's got certain, there's certain regulations on how deep it is and how wide. We won't get into that. Just know that if you have a fan on the ground where I could reach my hand in and touch it, it's got to have a guard on it. Now, if I take that fan and I put it on the ceiling, and the ceiling is 10 feet tall, I have now guarded that exposure by distance. I'm sorry, I've guarded that hazard by distance, and I've taken away an exposure. Unless the person's a giant, they're not going to be able to just reach their hand up into a fan that's 10 feet off the ground. Therefore, I don't have to have a guard. To do a hazard assessment and to say that that fan creates a hazard is incorrect because there is no exposure. However, if I have a maintenance worker that now gets on a ladder and climbs up next to the fan to do some kind of work, he's now being exposed. You don't necessarily need to put a guard on it. You could just turn the fan off and make sure it's discharged of any energy while he does his work, and you've eliminated that hazard. So it's important to understand that just because something is potentially dangerous and could be a hazard, if there's not a worker that's exposed to it, there's nothing to be done. And then when you get down to your risk assessment, like we talked about in the other PowerPoints, you start to add your probability and severity, and that's how you get your risk assessment. And then, like we spoke last time, you identify which ones are the most severe or the most probable, and you set up a flow chart on what you're going to fix. So lots of ways to identify safety hazards and where they come from. So these are just some types of safety hazards. General housekeeping is cleanliness. Are the aisleways clear? Can somebody walk without falling, etc.? Slips, trips, and falls. We spoke about that briefly. In winter on campus, they do very well at getting the snow and the ice to avoid a trip hazard or a slip hazard of ice. Electrical hazards, machines and equipment. That goes back to machine guarding. Are all the dangerous points of the machine guarded against a person putting their hand in there? Maintenance operations, fire protection. The process flow is how people and materials flow through a factory. And again, you have workplace violence, ergonomic issues, and poor emergency procedures. Health hazards are another thing that we want to identify. You have chemical hazards, and we'll show you a safety data sheet to show you what comes with chemicals. There's physical health hazards that can cause safety issues: noise, vibration, heat and cold, different types of radiation, pressure. Many of you may have worked somewhere where they either kept it really cold or really hot. Those can cause occupational injuries. Biological hazards, you could have infectious diseases within the workplace. You could also have a mold or an allergen that's in the walls if it's an older building. Those can all cause occupational injuries and illnesses. So this is a safety data sheet. As we look at it, it has 16 parts. It goes back to the global harmonization uh, uh, GHS, where all the world went to these. Before they standardized them, they any chemical company could make up their own format, and we'd get them from all kinds of different countries. Uh, in different formats. Now all of them are formatted the same way. There's pictographs. They all talk about they all have the same type of pictures. All the pictures mean the same thing from country to country. Uh, that's some of the information that's on it. Your hazard information, first aid handling, what type of exposure you can have, physical properties, the toxicology, and how to correctly dispose of it. Your exposure limits. And for those that are unfamiliar with what exposure limits are, this is the amount of a chemical that you can safely inhale or work around at your workplace before the potential for harm. So where it talks about 500 parts per million, that's in the air. So if you had a air monitor and you were monitoring real time, which they do make, and it became 501 parts per million, your air monitor would notify you that the atmosphere has become unsafe to breathe. Um, and as you can see, so you have the exposure limits, and then underneath, this chemical company has said, here's some engineering controls. Ensure adequate ventilation. So if you're working outside with this chemical, the likeliness that you would be overexposed is little. Here's the toxicological information. And as you can see, we have a rat, a skin rabbit, and an inhalation rat, LDL or LD50. And remember what LD50 means? Um, that's the lethal dose. It'll kill 50% of the population. And so we look at this and we say, okay, a rat was given 5,800 milligrams per kilogram of this chemical, and 50% of the population died through oral. Skin absorption is what it talks about, the skin rabbit. So it took 20,000 milligrams per kilogram on the skin of a rabbit to kill 50% of the population. And then inhalation is breathing. Also underneath the information is the acute effects um, and the local effects, chronic effects. So down carcinogenic effects, that's cancer causing, down at the bottom. So this is saying this product is not considered a carcinogen. So that's good. You wouldn't have the chance for cancer. Skin corrosion, irritation, and epidemiology for this specific chemical. So hazard control. The last step was hazard assessment. And so we used our tools that were available. We investigated. We listened to the employees, what their concern is. We went to the chemicals, SDS, and now we need to control it. So one of the things, and this, again, very important, going to be on the test, is we're going to use the hierarchy of controls. And here they are. So this is a pyramid, upside down. Very important that you understand this pyramid. The elimination, substitution, engineering controls, administrative controls, and PPE. Now, PPE is probably the most common one you'll see. Everybody wears hard hats and safety glasses, but as you look at the hierarchy of controls, it is the least effective. So, as we go through these, elimination, you physically remove the hazard. So I take the hazard and I do something, and the hazard's gone. So an example of eliminating a hazard would be we have a very say we have a strong carcinogenic, so it causes cancer, chemical we use for cleaning, and we just don't feel comfortable using it anymore. And lo and behold, here's a non-toxic chemical made by Johnson and Johnson that came on the market that does the same thing. By now purchasing the Johnson and Johnson product, I've eliminated this dangerous product. There's no more hazard of that chemical. Same thing with substitution. You're replacing the hazard. So chemical wise, we can use the same type of thing. You have a hazardous chemical. Instead of finding something that's completely non-toxic, we found a chemical that's less toxic or less of a hazard, and we replace our most dangerous chemical with a less dangerous chemical. Engineering controls, you isolate people from the hazard. Think of this as the guarding. So when we put a cage on a fan, we're guarding that fan. We're isolating you from the fan blades. You're not getting into it. We've engineered it out. Another way to think about this is if you have something that creates lots of noise, you can put up noise canceling barriers or soundproofing in between the worker and whatever's causing the noise, and you're isolating that noise from them, and you're reducing the hazard. Administrative controls are policies, procedures, and the way people work. And then PPE is protective equipment that is the that's the least effective because it requires on the worker using it correctly. So just to wrap this up, you want to seek to eliminate first, substitute with less hazardous, provide engineering control. Our example here is placing a guard. Then you have administrative controls. Something I didn't talk about on the last one is training. If you train somebody, that's administrative. Warnings, so a stop sign is actually an administrative control. And then you can limit people's exposures. If you have an area, a good one on this is places that have deep freezers that to keep everything really, really cold. They'll rotate which employees work in there, and maybe it's a time rotation. Maybe they only go in once a day, or maybe they only go in for 15 minutes, and then somebody else goes in, so the cold doesn't cause an injury. And as we've said, the least effective and the last resort is your PPE. Moving on our core values of your safety program is education and training. They're very important. There's lots of companies out there that offer this. Most companies will have their own internal education and training program. They get consultants to come in. But one of the resources people forget is that OSHA helps provide this and will help you educate and train your employees. Program evaluation and improvement. Part of the whole cycle of this program is that once you feel that something is in place, you take the time, you investigate it, you evaluate it, and you improve, and you move on. And then at another designated time, you should investigate, make sure it's going right, and then improve on it. It's a constant improvement process. Workers should be involved in this. They should be helping to identify what's working, what's not working. You should also have third-party or outside entities come in, evaluate your program. That way you get an unbiased opinion. So in summary, of what we've talked about is we talked about the core elements of safety and health programs. We talked about hazard identification, both safety hazards, the types of safety hazards, and the types of health hazards, hazard controls, and hierarchy of controls.